number of quarters she has, write the expression in terms of n that describes the number of dimes.
Okay, so we're going to look at this problem here, and it says, we're going to break it down in little parts here. So Lindsay has how many coins?
32.
32. Okay, so we want to have that information here. So we're going to put 32, right? That's how many coins she has. What's the next part?
In her change purse that are either dimes or quarters.
So these are either going to be dimes or quarters. Okay? Keep going.
If n represents the number of quarters she has, write an expression in terms of n that describes the number of dimes.
Okay, so if n is the number of quarters she has, right? So n is going to be our number of quarters. And I'll just put a little hash mark there for number, right? That's going to be our n is our what?
Variable.
And what we talked about in algebra, a variable is what? What did we say it was? You can look at the board.
A letter.
It's a letter, right? We use a letter to represent something because we don't know what it is yet, right? It could change, or it could be something that we haven't figured out, right? So n is the number of quarters. She has 32 coins, and they're either dimes or they're quarters, right? It's one or the other, okay? So how many total coins does she have?
32.
32. So if we want to find out how many dimes she has, how would we find that out? What do you think? That's tricky. You want a hint? Okay. So the total quarters and dimes that she has is going to add up to
32.
32. We know she's got 32 coins. That's as many as she has, right? So if we took away all the quarters, what would we be left with? If we took all the quarters away, what would we be left with? No, don't look at this. I'm not asking numbers. You're thinking numbers still. Look at the problem. It's made of these two things, right? Dimes and
quarters.
So if I take away the quarters, what am I left with?
Dimes.
Dimes. So however many things are left when I take away the quarters is how many dimes I have. So if I have 32 to start with and I subtract all of the
quarters,
then I'm going to be left with
dimes.
Dimes. How many dimes? Well, how many quarters do I have? Do we know? Do we know the exact number?
No.
We have a variable, right? What's our variable?
Quarter?
What's our variable?
N.
N. N's our variable. Because in algebra, remember, a variable is going to be the letter, right? You remember that? So if we say 32 total coins and we subtract our quarters, that's a variable. So 32 minus what?
N.
N. That's going to equal what? We got rid of our quarters, so what are we left with?
Dimes.
Dimes. That's going to be the number of dimes we have. So what is our math that we're working with?
32, take away.
How do you say take away? What's a better way to say take away?
Subtract.
How do we do that? Starts with an M.
Minus.
Minus, exactly. 32 minus
N.
32 minus N. So 32 minus N is going to give us how many dimes we have, right? So what do we think we should try?
32 minus N.
Give it a shot. See what it says. What does it say? Does it want you to change the format?
I put it wrong.
Oh, yeah, because, yep. Yeah,
I forgot.
you forgot, yeah, we weren't, because we don't know the number of quarters. What's it say? Excellent, exactly, man. Good job, dude. That's what I'm talking about. Bump it up. Boom. All right, what's next?
A team is ordering sweatshirts and sweatpants for its players. Each sweatshirt costs $28 and each pair of sweatpants costs $15. Write an algebraic expression to represent the total cost if X players want sweatshirts and Y players want sweatpants.
Okay, so sweatshirts and sweatpants, right? This team's ordering because they want to look fly, right? They want to have the game, be all looking good when they show up. Okay, so let's start at the top and read the first part of that question again.
A team is ordering sweatshirts and sweatpants.
Yep.
For its players.
So we know it's going to be these two things together, right? So we're going to be doing what? How would you put things together in math? If I said I had two of something and I wanted to have one more of something, is that going to be subtraction? Is that going to be division?
Add.
We're going to be adding. So this is going to be an addition problem, okay? Okay, good. What else?
Each sweatshirt costs 28 and each pair of sweatpants costs 15.
Okay, so the sweatshirts cost 28 and the sweatpants cost
15.
15. Okay, cool. What's next?
Write an algebraic expression to represent the total cost if X players want sweatshirts and Y players want sweatpants.
Okay, so we don't know the number of people that want sweatpants or sweatshirts. We just know it's X and Y. So we're going to use these. And what are these called again?
Letter.
Which is called a
variable.
A variable, my man. Exactly, a variable. So we have our variables here. So X number are going to want sweatshirts and Y number are going to want sweatpants. But we don't know how many that is, right? So what this is going to be an addition problem, but also what kind of math are we going to use? Because if you have $15 and you need it Y number of times, how are we going to figure that out? What kind of math is that? So many times. What kind of math uses times? Is that subtraction? Is that division? Is that multiplication?
Multiplication.
Multiplication, right. So what we're going to say is Y amount of players want sweatpants. How much does a pair of sweatpants cost?
15.
15. So it's going to be Y times what? Y times how much does they cost?
Times 15.
My man, exactly. So Y times 15 is however many sweatpants it is. So remember when we talked about variables, right? We said sometimes it's a number that's set, it doesn't change, and we just have to figure it out. But sometimes it can change, right? We don't know what the number is going to be. It could be all sorts of different things. Well, right here, as long as we know that it's $15 for every pair of sweatpants, then no matter what this is, we can find the answer, right? Because if only one player wants sweatpants, then it's going to be one player times 15. So it's going to be 15 times 1. It's going to be $15. If two players want sweatpants, it's going to be 15 times. If it was two players, if Y would be 2, then it's going to be 15 times
2.
2, exactly. If it was 4 players, then it would be 15 times how many players?
4.
4 players, exactly. So right here, we don't need to know what this is exactly, but we can figure it out because no matter what this is going to be, if we know how many players it is later, we can do the math. Okay. So this is times, and then what else we said? How many players want sweatshirts? X, and it's going to be each one times how much money?
$28.
28, and that's going to be in brackets, right? So now this times this is going to be how much they get total for the sweatpants. This times this is how much they're going to get for the sweatshirts. But we said, what kind of problem is this?
An addition.
It's an addition problem, right? So let's look at the last part of the problem there. What's it say? Write an algebraic expression. An expression is just like this, right? Where we can work out the math once we plug in the numbers to represent the total cost if X players want sweatshirts and Y players want sweatpants. So what's our algebraic expression?
For Y. Y.
What's that symbol? When we do the dot? It's because we have X, we do it here differently. But this kind of problem, we said it was a multiplication. So this is times. Y times 15, yep.
Plus X
times
28.
28. And here, actually, what you can do in this one, I wrote this one maybe a little bit messy because usually you do X before you do Y. So we could do plus Y times 15, right? That's the same thing, I just moved it around. So, you think you can plug that in? Because remember, you have to put in the
brackets.
The brackets, exactly. Good job, dude. So give it a shot. Put that in. Let's see what we get.
It says I don't have to put in the dollars.
Yeah, because we're not putting in the dollar sign because we're not worried about that. We just know we know we're talking about dollars down here, right? Good job.
I'm pretty sure this. Is this a bracket?
That's one of them, but that's not the one that we normally use. So that's the square bracket. The one you're going to use is right here on the 9. So you hit Shift and 9, and that's going to be the bracket.
All right.
So what do we get here? And you're going to say X.
So X.
Uh-huh. And then let's look for the time symbol on here. Did they give it to you? Oh, they give you all sorts of stuff. Boy, howdy. Let's close this part here and let's see what it gives us. Oh, how does it let you open that up? How did you have that up? Did it just automatically do it, or is there a way?
No, it was right here. Then I think I clicked something next to it. Then all of them popped up.
Oh, I see. Okay. Here, let's see.
No, it was.
Oh, hold on. Math tools. Let's see if that does it. Nope, that's not it. That's not it. Yeah, I don't know how it took it away. Let's see. Oh, there you go. Okay. Oh, right there. Boom. There it is. Multiplication dot.
Multiplication.
Yep. And then
28.
28. Yep. And then you can put the other bracket. Do they give you the brackets in this one?
No, I don't think so. They just used that one, I think.
That was weird. Okay.
I don't see any. All those.
Yeah, no, I don't either.
My eyes.
Okay, so on this one, you put the left bracket again. So this is going to be the right bracket.
Oh.
Right? So they're going to hug it. Right? The brackets hug the thing. So yours were facing the other way.
Right.
So, okay, and then.
Do we put
then
the
what
plus?
we put? Yep. You're all right. One step ahead of me, man. You got this.
X. No, Y.
Yep.
Y.
And then what do we?
Multiplication dot.
And then what was the rest of the problem? We got it right here on the board.
15,
if you need to
15.
Oh, you are, man, you don't even need to look. You got this.
15.
And then remember your last bracket.
Bracket.
Yep. Let's give that a shot. What's it say?
Well
Well done. My man, you're killing it. That's what I love to see. Good job. All right. So we're learning, remember, we're learning what the variables are, and we're learning how to set up the problem into an expression, okay?
It's 7:15.
All right, let's see what we got here. All right.
And Connor and Cassie are selling peaches yesterday. Connor sold 33 pieces. Cassie sold more peaches than Connor. Write an algebraic expression that represents the number of peaches Cassie sold yesterday.
Okay.
Use pencil and paper, which we're going to be using now.
Yeah, we got that.
Suppose Cassie sold 52 peaches today. Explain how to write an expression for the number of peaches Connor sold today if Cassie still sold more peaches than Connor.
Okay, so we're going to break this down line by line, okay? Because there's a lot going on here.
Yeah.
So that first line, it says Connor. So Connor sold how many peaches?
33.
33.
And Cassie sold P.
Cassie sold, read the whole thing. Cassie sold, what's it say?
Cassie sold more peaches than Connor.
P more than Connor. I messed that name up. I don't know anyone named Connor. Oh. Okay, so she sold P more than Connor did, right? Well, how many do we know Connor sold?
How many did?
Yeah,
Connor sold
Cassie sold P more than Connor, but how many did Connor sell?
33.
33. So P more than, we can change this right here because we know what it is. P more than what? How many did he sell?
33.
33. So P more than, what does more than mean? How do we do more than in math? Is that subtraction?
Addition?
Addition, yes. Good job.
There's addition with a lot of them now.
So it's going to be P plus 33, right? That would be the way to solve that. So what you could do is you could just move these a little closer together and say P plus 33. So Connor sold 33. Cassie sold
P plus 33.
P plus 33. Okay, so let's keep reading. What's the next part there?
Write an algebraic expression that represents the number of peaches Cassie sold yesterday.
So, an algebraic expression. Is this an algebraic expression?
Yes.
Why?
Because there's a P.
There's a P. That's called a
Variable.
variable, my man. Exactly. This is our variable. So, is this an algebraic expression?
Yes.
P plus 33? Okay. So then we already know how many she sold yesterday. P plus 33. Or 33 plus P. We could say it either way. Cool. What's our next part of the problem?
Suppose Cassie sold 52 peaches today. Explain how to write an expression for the number of peaches Connor sold today if Cassie still sold P more peaches than Connor.
Okay. So this I put a Y next to these so we know this was yesterday, right? But this is today. So Cassie sold how many?
52.
52. So she started at 52, and we have to figure out how many did Connor sell, right? So that read after that first part, it says that she sold 52, and then it says find out.
Explain how to write an expression for the number of peaches Connor sold today. If Cassie still sold P more peaches than Connor.
So she still sold P more, right? So in this case right here, right, with Cassie, let's say this number was 7, right? She would have sold 7 more. So her number would have been 7 plus 33. So she would have sold 40, right? If we say that's what that is. But we don't know what the number is. But whatever it is, she sold this many more than him, right? So we said 33 plus P was yesterday. Well, here, we don't know how many he sold off the bat, but we know how many that she sold, and it was going to be P more than, right? So if we need to find out, we have to go in the opposite direction because we don't know what Connor sold, right? But we know that she sold more. Yeah, go ahead. What do you think?
I think that it's like reversed in numbers. I think it's like yesterday, Cassie sold 52 plus 33, and 33. Connor sold 33 that day, and yeah.
Oh, I see what you're saying. So you're thinking that this could stand in for this, maybe? Well, we don't know right now what it is, but remember in the problem it says that she still sold today P more. So we still don't know what P is. But we know what she sold, and we know it was more than what he sold. So if she sold 52, he had P amount less than 52. So how do you say something less than in math?
Subtract.
Yep, it would be a minus symbol. Minus how many more? What was our variable?
A variable P.
So if she sold 52 and he sold P less than that, you could start at 52 and subtract whatever P is, and that would find out how many he sold, right? So is this algebraic expression?
Yes.
Yeah, just like this is an algebraic expression. Okay, so now what does the problem say it wants us to put in? It wants us to find, your screensaver, come on. Okay, so an algebraic expression that represents the number of peaches Cassie sold yesterday. So where's our yesterday math? Is this yesterday or is this yesterday?
That's it.
It's the one on top. So how many did she sell? How many did Cassie sell? What's our algebraic expression?
P plus 33.
My man. So what are we gonna try putting in there?
Bracket P plus 33.
On this one, I don't think you have to put in brackets because it's the only thing that you have in there, but you can do it if you want to. But just go ahead and try putting in just
P plus 33.
See what that gets you. See how that likes it.
Well done.
Well done. So remember the words that we're focused on. So when you read a word problem, you have to think about what are some of the things it's asking you, right? So when it says something is more than something, what kind of math is that?
Addition.
It's addition, right? And if it says someone sold less than someone else did?
Subtraction.
Subtraction, exactly, my dude, exactly. So, does that have a follow-up question or is that just the one?
This is the next one.
Next one, what's it say? Manuel
Manuel makes $8 per hour.
Okay.
He has worked 6 hours so far this week. How much has he made so far this week? Write an algebraic expression that describes how much he makes for T hours
Okay.
of work.
Okay, so the first time he said he makes $8 an hour. Is that what it said? I want to make sure I have that right. And he's worked how many hours?
He's worked 6 hours so far this week.
6 hours so far.
Yeah.
Okay. All right. So if we wanted to just find that, how would we do that? $8 per hour. $8 for every hour. What kind of math would that be? Is that addition? Is that multiplication?
Addition.
It could be addition if you added up all the hours. What's an easier way to do that? Instead of saying 8 plus 8 plus 8 plus 8, you could just say 8
Multiplication.
multiplication, 8 times
6.
how many hours, right? Exactly. So for this one, if you want to find this out, you could say 8 times 6, and that would give us $48, right? That would be what it would be there. But it's not asking us that. What's the next line say?
Use pencil.
Nope. Sorry. I got you on the wrong spot. Right here. Write
an algebraic expression that describes how much he makes for T hours of work.
T hours. So if we don't know how many hours he worked, we just know he worked T hours, right?
Mm-hmm.
So it's going to be T times what?
T times 8?
T times 8, my man, that's what's up, exactly. Because he makes $8 every hour. So we don't know how many hours, but we know it's a T. So it's going to be T times 8. And that's going to give us however much money he made. So the first part there, it does ask, it says, right before that, it says on there, how much has he
made so far this week?
So we know that answer. How much has he made this week, so far this week?
48.
$48, right? So here, this is our algebra, because this right here, you could change T, and you'd be able to figure it out, right? If I make $8 an hour, and I want to say, well, how much am I going to make for 10 hours? I just put 10 right here. I plug it in for the number of hours, and I say 10 times 8 is going to give me 80. But what if I only work 2 hours? Well, then I'm going to say 2 hours times 8. That's going to give me 16, right? So I can keep this. This right here is the formula. This is going to work no matter what. This is an algebraic expression, and no matter what number I plug in here, I'll still be able to find the answer, right? So what is the question asking you to fill in here? It says how much, he has made.
How much he has made so far this week.
So how much has he made so far this week? Well, what did we say? Look at the board.
6 hours.
So he worked 6 hours at $8. Did we already do that math?
Yes.
Where is it? Right here?
Right here.
Here?
Yeah.
So he's made how much?
48.
48, exactly. So give that a shot. See if it likes that.
$48?
$48, right? Because he worked 6 hours. He did $8 per hour. So yeah, 6 times 8, 48. What's it say?
Good job.
Good job. Crushing it. All right. Does that have a follow-up question, or is there another one?
The follow-up.
What's the follow-up?
An algebraic expression that describes how much Manuel makes for T hours of his work.
Oh, feels
What
like
work?
we already figured this one out too, huh?
Yeah.
So what's our algebraic expression? Is this an algebra? So real quick, is this an algebraic expression?
No.
No, why not?
Because there's no variables.
There's no, my man, that's what I love to hear. Yes, no variables. How about here?
Yes, that's right.
Yes, because there's a variable, T.
Yeah.
Right, so is this our algebraic expression that
Yeah.
says how much he's going to make in T hours? Plug it in. Plug it in. Oh, dude, you were on top of this. Killing the game.
T dot.
You say dot, but what does the dot stand for?
Multiplication.
Multiplication. So that's going to be times. T times 8. Or you can say 8T.
Nice work.
Nice work. That's what I'm telling you. It's just backing me up, man. You know, it's not just me. I'm not just, kissing up to you. I'm not giving you praise that you don't deserve, man. Even the computer knows you're killing it. New question?
Jackson and Isabella's teacher asked them to write an algebraic expression for the quotient of 32, and D. Jackson's answer was 32 divided by D. Isabella's answer was was D minus 32. Which student was correct? what was the incorrect student's error?
Okay, so let's read that from the beginning there. We'll go a little slower. So what's it say?
Jackson and Isabella's teacher asked them to write an algebraic expression.
So he wants them to write an algebraic expression. Are these both algebraic expressions?
Yes.
Yeah, so we know they got that part right. Okay, keep going. What's it say after that?
For the quotient of 32 and D.
So the word is quotient.
Quotient.
The quotient of 32 and D. So have you heard that one before when we talk about math? The quotient? It's popped up before. So if you say the sum of something, that means you're adding it, right? If you say the difference, that means you're going to subtract. When you say the quotient, what's that for? Do you know what type of math? What operation? It's going to be dividing.
Dividing.
Yep, that's division, okay? So it needs the quotient of. Okay, so what's the rest of it say?
Jackson's answer was 32 divided by D. Isabella's answer was D minus 32.
Mm-hmm. So if we look here, so you can always click on this part right too where it says the view an example, right? And this won't change the problem. So it tells you here what an algebraic expression is. And it says the word quotient suggests division. So if it says quotient, you're not sure, and you don't remember, if you see a word like this and you're like, I don't know, that little button there, you can click that, and that will say, that'll show you what they're talking about. So right here, it says Jackson's answer was 32 divided by D. You could write it like this, or you could also say 32 divided by D. That would work too. But this is division, and Isabella did subtraction, right? D minus 32. So which one is the quotient? Which one did we say is a quotient?
Jackson.
Jackson, because he did division, right? So this is the right one. So what does the question ask you?
Which student was correct? What was the incorrect student's error?
Okay, so for the fill-in question, which student was correct?
Jackson.
Jackson, okay. Plug that in.
Excellent.
Excellent.
And the follow-up question, what was the incorrect student's error?
What was the incorrect student's error? So what's wrong about this one? Why doesn't this one show the quotient?
Because, wait, why doesn't it show the?
Yeah, this one shows the quotient, right? Because it's
division.
It's division. Is this division?
Nope.
So it's not correct because this doesn't show you division. It's not the quotient because there's no division here. This is subtraction. This would be the difference. Yeah.
There's three buttons that you press on the screen.
There's 3 buttons?
Yeah, there's A, B, and C. It says the A is the student used the incorrect operation and the incorrect order of the terms.
Mm-hmm.
B is the student used the incorrect operation, and C is the student used the incorrect order of terms.
Okay, so what they're saying right here is, did Isabella get it wrong because she did the wrong operation, so the wrong type of math, right? Did she do the wrong, she was supposed to use division, instead she used subtraction? Or is it saying that she got them in the wrong order? Should she have done 32 minus D? Would that have...
No.
That's not going to help her either, right? So is it saying that she got them both wrong? Did she have them in the wrong order and she used the wrong operation? So you have to pick which one.
Yes.
So does it matter the order if you're doing subtraction?
I think it was B. The student used the incorrect operation.
Okay, let's give it a shot. Let's see. Oh, so what's it say? The incorrect expression compared to the correct expression to find the error. So what about this one right here?
And then
Because the incorrect order of the terms, right? So on this one, it says the quotient of 32 and D. So the order, so she not only used the wrong operation, she did it in the wrong order because it says 32 and D, right? So 32 is what she started with. So if she was doing over here, this one says the quotient of 32 and
D.
Right? If you did it the other way around, if Jackson did it like this, is that right?
Mm-hmm.
That's going to be a way different answer. That's not going to be right because this is the quotient of D and 32. This is the quotient of 32 and D. You see what I'm saying?
Yeah.
Right. So on this one, the order matters as well too. So you were right on that. That's why I let you take a guess on that one. But I wanted you to see the difference, okay? So the order makes a difference too. She put them not only in the wrong order, she also did the wrong math, okay? So it was both of them. You see why it's A now? Okay. Cool, cool, cool.
It costs $225 to rent a room at
225 what?
dollars.
There we go.
To rent a room at a event center. The event center charges an additional $11 per person for food. Write an algebraic expression for the total cost of an event for n people.
And we need n people. Okay? So, we're going to be doing a couple different types of math in this one, right? So, how much does it cost to just rent the room? Even if you don't feed anyone?
225.
225. So if you feed 0 people, it's still 225, right? What if you feed 1 million people? Does this change?
Yes, by a lot.
By a lot? Or it says to rent the room?
No.
That
to rent
changes.
the room, that changes.
So does the cost of the room ever change?
No.
So it's always 225, right?
Yeah.
So we know 225 is in there, right? And then there's an additional cost, right? It said there's an additional cost?
Yes.
So think of that word. Additional cost. What does that sound like? Additional.
Plus.
Addition, right? It sounds just like addition. So we know that we're going to be having this, and then we're going to add on to it. Plus, how much per person?
11.
$11 per person. So how do we say per person? How would we do that?
Per, like, each person.
Each person. So that's going to be what kind of math? For every person. So what if there's 5 people? It's going to be 11. What?
11.
What do you think? I'm not saying solve the problem, but it would be $11 for every person. And how many people are there?
It is 5.
5. So it's going to be 11. What 5? What operation do we use?
I'm thinking either between multiplication or addition.
So multiplication and addition are both kind of the same, right? It's just you're doing one. If you wanted to do addition, you would say 11 plus 11 plus 11 plus 11 plus 11, but that would take a long time. Yeah.
So minus?
No, not minus. You were right in the first time.
Division?
Hold on. No. You're second guessing yourself. You had it right the first time, okay?
Oh.
So if it's addition and you said 11 and there was 5 people, then it would be 11 plus 11 plus 11 plus 11 plus 11. But that would be like a long, hard way to do it. Instead of doing all that, you could just say 11 times how many? How many people?
220.
That's how much it costs to rent the room.
No, 5.
How many people? How many people are there?
N people.
N. So it would be 11 times what?
11 times N.
11 times N. And that's going to tell us. So if this was 5, like we said before, then it would be 11 times 5. But what if it's 100 people? 11 times
100 people.
Right. What if it's 1 million people? 11 times
1 million people.
What if it's 1 person? 11 times
1 person.
1, right? So this could be 11 times whatever. So it says we have to figure it out how much it's going to cost, and we don't know. We don't know how many people we're inviting, but can we still come up with an expression that'll let us find out?
Yes.
So this right here is our expression, right? Because where do we get the 225 from? What is that?
The cost of the room.
That's no matter what, right? If we serve 1 million people, if we serve 50 people, if we serve 0 people, we still rented the room, and that cost us $225. So that's there no matter what. Then it said additional cost, and we know addition is, like you said, plus, right? That's adding. Then it's $11 per person. So anytime you hear something is something per, right? $15 per t-shirt. Right? Or like we had the sweatpants earlier, right? $15 per sweatshirt, $23 per sweatpants or whatever it was. That's going to be per. So that when you hear per, that usually means multiplication. So 11 per how many people? Well, how many people do we have?
5.
Well, that was our theory.
And.
We have and though, right? All right, give me 1 second, my man. Room 4, Mr. Nixon. Hi. Do I have any students? What? Yeah, I have one right now, but I can try and see what I can do. Yeah, I do. Okay, sorry. Bye. Okay, so we had said, yes, this is going to be however many we have times the number of people in there. So did you put that in? Okay, so it says an algebraic expression for the cost of an event for n people is, well, where's our algebraic expression in here?
The n.
Is it just n?
Yeah.
So
No.
you just write n?
Yeah, just n.
What are you going to write for the whole thing, for the expression?
225 plus bracket 11 multiplication dot n.
Yeah, so 225 plus 11 times n. Or you could also write this as just 11n, right? That would work too. Okay, give it a chance. Plug it in. See what it gives you. See if it likes it.
Eleven multiplication dot n.
You could do either. You could do either. It means the same thing. So if you see where it says like 11n, if you put a number right next to a letter or a variable, that usually means times.
All right.
What did it say?
That's incorrect.
Okay, let's see here. What does it say? Well, hold on. Oh, no. Okay, so what it is you wrote just this part. We need to put in the whole variable because you didn't talk about renting the room, right? Remember? So it's the whole thing. The whole thing here is going to be our variable, right? Or I'm sorry, our expression. Because it has the variable in it. It's algebraic because it has a variable. But if you're just charging per person, you haven't said how much the room costs. So that's that cost that you have to make sure you put in every time.
11 multiplication n bracket. Oh no, wrong. Try again.
Okay, hold on. Don't get rid of the thing yet. Let's see what it says. First define what the variable represents, then identify the operation needed. Okay. Plus 11. Yeah. So let's try this. Let's try it without the brackets. And let's just try that. Because that's the same thing we said, right? Let's give that a shot and see if it likes that. Oh, you know what we didn't do? What did we write down?
225.
What did you write down?
Oh.
We didn't check our numbers. That was my fault too. I was looking at the expressions there. We need to make sure we wrote the number. So we knew how to do it, but it was 225 and you wrote 2.
So it would have probably been right the first time.
It would have been right the first time, but we wrote
55.
55. So, and I make mistakes like that too, right? Sometimes you make mistakes and you're not paying attention to the little details, and I was worried about the big math, the brackets, and everything like that. I didn't see that you made it 255 instead of 225 too. So that's also my fault, right? But we all make mistakes and we can learn from them, okay? So that's totally cool, all right? But we know that the math that we were doing, if we'd got this number right, because we knew what it was, if we'd have put it in right, we would have got the right answer. So that's okay.
I was thinking 255.
Yeah, it threw me off too, because I didn't catch it when you said it. I was like, wait, that looks right. Because I didn't see that this was swapped around. That's, well.
If you would have said anything, I wouldn't have noticed.
I wouldn't have either. It caught me for a second because I hit enter and it looked like it was the same thing. I was like, what's wrong? It's the same answer. No, the number got swapped. That's on me. So, but we learned from those, right? Good job.
What are two different word phrases for the algebraic expression m plus 3? Use pencil and paper. Write a few more word phrases that represent the given expression.
Okay. So m plus 3. Remember we were talking about ways that you can see this and you can say how it's said? So we said earlier when we talked about the last problem, we said something where it was additionally, there was an extra cost, right? Additionally means addition. So we're adding, right? If this one right here, you were talking about this, I have m. Let's say I have m number of markers. Right? I've got some markers in my hand. You don't know how many there are, right? But you have however many I have plus 3. So you have what? 3. How can you say that you have extra or more than I have? What do you think?
Trying to think of the past one.
Yeah, trying to think of some of the examples. Well, I just said something that was kind of interesting. If I have 3, what was the word I used?
3 pen markers.
3 markers.
I didn't know how many there were.
So I have m. You have how many more? How many more do you have than me?
3.
3. So 3 more than.
3 more than.
Right? So you could say, one of the ways you could say that would be 3 more than M. Right? Wouldn't that be one of the ways you could do it? Okay. So what else?
I think that was the whole thing. What are 2 different word phrases for the algebraic expression m plus 3? Use pencil and paper. Write a few more word phrases that represent the given expression.
Okay, so on the examples it gives, I didn't see it gives us examples there. So it says, what's that first one it has? The first answer it lists.
What are 2 different?
No, on the clickable thing.
Oh.
What's that say?
3 more than m.
Oh, that's what we just put up there, right? 3
Yeah.
more than M. What's the second one?
The product of m and 3. M.
Okay,
times,
hold on. Product of M and 3.
Product of m and 3.
Okay, what's the next one?
M times 3.
And the last one?
The sum of m and 3.
Okay, so 3 more than M. Is this 3 more than M? Is that more than? Is that adding?
More than m.
Yeah, so this one's right?
Yeah.
Okay, what about the product of? What did we say the product was? What kind of oh, I almost just gave you the answer. What kind of math is that? Is that dividing? Is that adding? Is that multiplication?
Multiplication.
It's multiplying, right? When we say product, that means multiplying. So is this multiplying? Is this right here multiplication?
No.
No, so that's not right. M times 3. Well, what kind of math is that?
Times.
Which is
multiplication.
So that's not right. The sum of
Addition.
M and 3. That's addition. So is that one the same?
Yeah.
Yep. So which ones are right?
3 more than m
Yep.
and the sum of.
So check those. Check your answers, and then we'll head back to class.
So A and D.
You tell me. What's it say?
Excellent.
Good job, dude. All right, so we'll keep working on this some more tomorrow, okay?
All right.
All right, brother. Good work. Take this home. Try some of this stuff on your own, okay? See if you can knock it out tonight. Do some homework, all right? All right, man. Thank you.